I've just solved problem 4, time for problem 5 of Advent of Code 2024. Print Q. Elf must recognize you. Slay launch safety manual. Specific order. Notation X pipe Y means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. So it's ordering X goes before Y. So those are the rules, edges, and we wonder if this is good order. So it's like topological sort problem, but we don't need to sort, we just need to check which updates, which lines are in good order. What do you get if you add up the middle page number from those correctly ordered updates? Is it always odd? The word odd is not mentioned. Middle. I will put an assert that everything is of odd size. So if this is good order, then the middle is good. Then the middle should be added to the answer. Get puzzle input. Maybe I will stop hard coding the data size and start reading until end of file. There is input. All right, and there is one empty line, which is slightly annoying, but it's there. C++, read until elf. Do I want to use sin? But it's so convenient. No, I need to read to a string because of this. Right. Okay, then let's read until elf and in some way detect. So first part is to correctly read. Let's focus on that, then we'll do the logic. While get line of sin comma s to something. If not is digit of s of 0, then continue, because this means it's an empty line. I think I saw one of those, or if s is empty. Otherwise, we need to split by a pipe or a dot. So maybe like that. For every position, starting from 0, if is digit of s of I, while is digit, grab s of I minus 0. This converts a character to a digit from 0 to 9. So I get a number, then do I++. Then you get to a comma or a pipe, or the end of a line, which is space, or maybe it usually will be end of line. We can put an assert there, which means which allows us to check that nothing went incorrectly. So now a character needs to be a comma or a pipe or a new line. I don't expect anything else. I don't know, let's print x, whatever. Then I++, because I++ will be done by a for loop anyway, so I don't need it. If I run this, do I get any errors? Ignore that. Yes, I do get errors. So let's print the line, and here let's print the index. We print this. Let me think. I'm not sure what is what. Let's print I is equal to this, X is equal to that. Okay, in this line 73, then we get to position 2, 0, 1, 2, 3, 4, 5. And at position 2, what do you have other than a new line? Unless it's a space? No, it should be a new line. Then let's also print S of I is equal to S of I. S of I is equal to what? What about printing the ASCII value of that? What is this character? S of I equal to 0. There is 0 character then there. Strange. Is it because of the way I copied? Huh. Well, okay then. Maybe it has something to do with copying from Windows. If I do this, then does everything work? Now we do read a lot of values, all right. Yeah, and then let's now collect into a vector the numbers v push back x instead of actually printing them. And now if there was a comma, this will be a Boolean flag. Then there is some order, let's say edges of v of 0 push back. No, if there was pipe, this means an edge. Push back v of 1. It's like adding an edge. I don't know the size, so in advance I'm just going to use a map. By the way, this is not efficient. You shouldn't use maps and dictionaries if it's not necessary. Arrays are significantly faster. In particular, map has an extra logarithm, but unordered map uses hashes, so it's not that much faster. Yeah, if I knew the number of nodes, the max value appearing, like 99, then I would just use an array here. This was supposed to be edges. So we have edges of this. I need a Boolean flag for was pipe. Here, if S of I is equal to pipe, was pipe is true. And else, this is a line apparently, right? Yeah, this is a line with a lot of commas, and I need to check if this is good order. So maybe for every x in V, no, we need to check if it's good order from left to right. So iterate like this. Now I'm looking at number x, let's say. For every y among edges of x, those should be later if they do appear. If they appeared earlier, this is bad. Now, appearing earlier I will put into a set, and if earlier count of y, then this is not okay. Okay is false. Also at this point earlier insert x. So as I go through numbers, let's say 725, when I look at 5, the set earlier should already contain 7 and 20, and I check if 5 should be before something that is actually equal to 7 or 20. So does this compile? No, it shouldn't, because we don't have this flag. And now if OK, then answer plus equal the middle node. Now will this work? Let's think. If size is 4, no, if size is 5, then this will give us, after division by 2, it will give us 2. 0 and 2, yes, this is a middle node out of 5. Okay, print answer, create answer. What do you want? Something wrong with brackets. I got something. Depending on how exactly you do it, you will get different time complexity, so let me comment on that. The way that I did it is first I read the input that's linear of input size, obviously. And then what I did is for every element separated by commas, let's say that there are, I don't know, q entries, q lines. Each of them contains k objects, separated with commas. For each of them, I iterate the output, the edges going out of something. So I will multiply this by out degree, whatever it is on average in the input or at max, multiplied by logarithm because I use a set. This logarithm, it's log of k, but this logarithm can be erased if you use unordered set, if you prefer hashes. So basically a hash set. Instead of this, there is alternative, at least one alternative. You could do q times k squared, possibly times logarithm again. If you iterated, if you did two nested for loops to iterate pairs x, y in the input. So if you have, let's say, 7, 25, 13, you can check, is there an edge from 7 to 20, or maybe from 20 to 7? Is there an edge from 5 to 7, 13 to 7, 5 to 20, and so on? Depending on whether k is big or the degrees and the graph is big, one of those two things will be faster. I went with the first method. Now, let's go to part 2 after this time complexity analysis. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. So we need to do topo sort of them. Their middle pages. Okay. I need to now run topological sort on just those few nodes. Part 2. It's strange to solve all those problems because the constraints are not mentioned. There is one test. You can usually do it with a brute force, and knowledge of algorithms doesn't help that much. All right, so here I want to, should I do topo sort or is it just some brute force? I will do topo sort maybe without recursion. Or do I want to use recursion? Well, let's use recursion just like I normally do it. Call it topo. For a node and few other arguments passed, what I will do is this. To some order, I'm going to push back a. Also, do we add middle pages only of the correct? After taking only the incorrectly ordered updates. Okay, so we ignore the correctly ordered ones. All right. We order push. What if there are multiple possible ways? Wait, what? I'm confused. Unless the pairs here specify the full order, or at least they will specify it. I wonder. Can there be multiple solutions how I can order something? I mean, otherwise the solution, the answer cannot be computed, right? So what? Well, still, let's do it this way. For every outgoing edge from A, if it's actually one of those things that is listed in this line, so I know present, if present count of B, present is a set of things that are here. If it's here, then decrease its input degree by 1 And if it becomes 0, then go topo sort to that node. So we pass by reference the order, the map. Let's make this global. I'm lazy. Not a good coding practice, but and there is also by reference the in degree. This is how many edges go into something. This is how topological sort works. We also need to pass here order and the in. Right. So now, if incorrect, create the order. What else do I need? The in degree. I guess I can compute in degree here, though it slows down the first part, but whatever. For everything, I can say plus plus in of y. There is also present. I forgot about that. Present is for things that are present in this line. Present insert x. So okay, for every object x here, for every y, if present count y, so if it's also here, then increase the in degree, saying that something else needs to go before you. Now there are some starting guys for everything in, did I populate present? Yes. For everything in V, if in of x is equal to 0, then you are a good starting node, because there is no requirement before you, there is no edge that points to you. For everything starting, run topo sort, passing this starting node, the order and the in. And order is there, then answer plus equal order of order size divided by 2. Present not declared. This is something I need to pass, and that thing does not change, so I will pass it with const. Well, do I get a non-zero answer? Yes, so let's try. Oh, I expected some mistake to happen, but here you go. I solved the task. How fast did people do it? The first problem they did in 55 seconds, which is very fast. I wonder how many of the top submissions are done partially with the help of AI. Though, of course, if you read the statement fast enough in Python, you can get very good time. Splitting by commas is trivial in Python. Oh, that was both stars? That fast? In 55 seconds? Okay, in 14 seconds, I don't think you can read the statement and understand, right? Can you? 14 seconds? How do I get to the problem? Problem 5. Yeah, 14 seconds is AI. If I'm wrong, I don't know. I want to see some recording. Okay, so problem solved. Time complexities would be similar analysis to the first problem, where it's strange to analyze it without some knowledge about the degree of a node. The upper limit for degree of a node is n if there are no edge repetitions. And the logic that I added is that we run topological sort, but only using the edges here inside. This also can be done without such normal recursive topo sort. We can make a loop that repeats a few times, that it tries to find which node goes next. So if I have, again, values 5, 7, 20, 15, I can iterate and for each of them try, I wonder if you are such a node that it can go before all three of those, and there isn't edge like from 5 to 20. So it's not that 5 is a requirement to be done before 20. If 20 can be first, we just use it first, greedily. And that would be just something of magnitude k squared if implemented correctly, where k is the number of those edges. Still, we need to first analyze, find which directed edges are present here. And if you decide to iterate pairs, then by the way, it's good to, at the very beginning, create a Boolean matrix, the adjacency, this thing, matrix, Boolean array n by n, showing which edges are present. But I went with just another method. Okay, problem solved. Thank you everybody for watching. See you tomorrow. Bye.